Hi, my name is Randall Restle. I'm the Vice President of Applications Engineering here at DigiKey. And in my position, I get an opportunity to see a lot of products that we stock. DigiKey makes it its purpose to find the latest technologies and the latest suppliers to enable you to develop tomorrow's new products. I was thinking about this, having done this for a couple of weeks, and I'm inclined to use the word awesome with what I'm going to present today. And I realize that in 5 years or so, it may not be awesome, but today I've brought some truly miniaturized parts. You know, a lot of engineers feel, and they have a model that says that electricity is going through the copper. In reality, electricity moves over the copper. It's a wave. It turns out that this device I have today, this is actually the package that it comes in. I'm going to take it out of its package to show you this. It's an enhanced gallium nitride transistor, and rather than conduct electricity through the device, the current travels over the device. And what that means is it doesn't heat up the device. And so with this being surface mode conduction, I have a device here that operates, there's a family. This is their Generation 5 series. This is a device that operates at 100 volts and 16 amperes. So 16 amperes goes from this without any problem. So we've seen an explosion in growth of gallium nitride devices, and this is an impressive one. So if you're looking for current density in your power supplies, in RF applications, because this is so small, there's very low inductance, which means it's a high-speed device. I've never seen a more impressive transistor device in the EPC devices. Now, or I should say in power transistor devices. Now, another device that I have happens to be also very small, and this is from a company called Murata, which makes passives and power supplies. And what I'm going to pull out of here is this is the plastic case that it comes in. We've cut the tape off to pull one of them out, and now I'm going to take my pocket knife and open this up to pull out just the device. It turns out that Murata is a company that develops a lot of its own materials, and in this device they have made a ferromagnetic material that acts as the inductor for a switching regulator. And what that enables them to do is, in this size package, they have built a DC to DC converter. This takes anywhere from something around 2 volts to over 5 volts and outputs a variety of regulated output voltages. So you can go from 2 volts to 1.8 volts. It's like 600 milliamps. And by virtue of the ferrite material that they've made, and they've put the regulator on top, this has very low electromagnetic radiation. So low noise and an incredibly small package. So this is literally a power supply that is a DC to DC converter. Now, to use this and to experiment, there happen to also be some development kits, so I can show you a board that has that on it. And I'm not even sure that we carry the board, but you can see the board here, and it's a development board, so you can put traces, or you can put clip leads, meters, scopes on it to see how it operates. But actually, the power supply is only this little section here. So incredibly impressive devices. I'd call them awesome, but given how time moves on, it's scary to say that. Thank you for watching.